Hello. Now we're going to do semi-structural formula. So we've just learned how to name carbon chemistry or organic molecules, the alkanes, alkenes and alkynes. And then we're just going to quickly show you what we mean by semi-structural formula. Now this contrasts with what we've been doing, which is structural formula, and that's where we draw the whole molecule and we use lines to represent the covalent bonds. And so on the naming sheets you would have seen drawings of those. In semi-structural formula, it's a bit of a throwback to when typesetting, the way that books and things are produced, and in that it was very difficult for them to draw lines on separate lines. Like if you used an old typewriter, you could virtually not draw a structural formula, so they had what was called semi-structural formula. So it's a bit of, but nowadays when you use Word and drawing programs and things like that, it's not hard to do it, but in the old days it was, before my time. That's how old. And so we still have to learn it. And so what we do is we can represent some of the structure of the hydrocarbon, but not all the structure, in the semi-structural formula. And so something like ethane, which is C2H6, and if we were to draw it, what colour we got? We would draw it as where there's a hydrogen on the end of those. And so the semi-structural formula for that is CH3, so 1, 2, 3, and then CH3. So you sort of work your way through the chain, and you name each component of it. Let's get rid of that. And so the semi-structural formula for ethene, which has a double bond there, is very similar, but you go CH2 and CH2, and you've got to recognize that there's a double bond in there. That's the tricky part in these semi-structural formulas, is recognizing that each carbon needs to have 4 bonds. So if you have a bond with a carbon and only 2 hydrogens, there must be another bond between the carbons, because that's the only other explanation. So that's the tricky part of it. When abbreviating a structural formula to its semi-structural equivalent, go carbon by carbon. So you work your way along the chain, basically. If you have any side chains, they're written in brackets to make sure that you don't confuse them with the actual chain ones. Okay, and they're written after the carbon that they're attached to. So here's an example. This is the first carbon atom. It's got 3 hydrogens, so it goes CH3, CH2, CH, and then this is a methyl group attached to this carbon. And then it goes all the way through. What's it say here? This carbon atom is attached to the carbon atom written before it, that one, and the carbon atom written after it. So there's 2 bonds, 1 bond, 1 bond, so that's why it only has 2 hydrogens. Okay, try and picture this as a fully structural formula. Okay, so here we have, this is a representation. This time they've put some kinks in it, and this is our chain. So if there's no side groups, we do not need to number the carbons in the main chain. And so the semi-structural formula is C with 3 H's, then the next C with 2 H's, the next C has 2 H's, and the next C has 3 H's. And that's what it looks like. And its name is butane. So there's no numbering involved because there's no branches. If there is a branch, we have to number it. Okay, and so that's just going back to our naming, and there's a methyl group. So our systematic name is 2-methylpropane, no double bond, no triple bond. And our semi-structural formula follows that trend. So our first carbon has 3 hydrogens, second carbon has a hydrogen and a branch off it, and then a CH3 coming at the very end. So what I want you to do here is have a go at naming the compound and working out its semi-structural formula. So what you should do now is just pause it, and name it. Alright, pause. You're back. Okay. No, you haven't paused it yet. No. Did you pause it? Okay, you ready? Okay. Right, let's do it. So, in terms of the systematic name, hopefully you recognize that you had a branch here, and so you could have named it from either end, and you'd get the same number there. So, and there's no double bond or triple bond, so nothing takes precedence, and so it's symmetrical around that carbon. So the name could have gone either way, and our name would have been 3-methylpentane. Now, what's our semi-structural formula? Hopefully we got CH3, CH2, CH, bracket, CH3, bracket, CH2, CH3. And the bracket is this guy here. Alright? Now, the functional groups. Now, in organic chemistry or carbon chemistry, the functional groups is huge. But we're only going to touch on it, a tiny little bit of it, and really we're only going to do the halogens as a functional group. But there's a whole lot of chemistry, like hydroxide is a functional group. Like functional groups are things that are added on to the carbon chain. And so right at the very beginning I showed you a video, a slide that showed all the other groups of organic chemistry, and we're only doing a tiny little bit of it, and the rest of it is pretty much related to functional groups. But we're just going to do the haloalkanes. Okay, and the haloalkanes, not halo as in the game. These are molecules that have one or more of the halogen, the group 17, or what I would call the group 7 elements because I'm old. The fluorine, chlorine, iodine, bromine. And remember, they're on your information sheet, and they're replacing a hydrogen on an alkane. And so this is a simple one where you've got methane, but because it's got a hydrogen replaced with a chlorine, it's now called chloromethane. No need to number it because it can't really be anywhere else. Could be over here, but it's the same if you just spin it around in space. You can have more than one halogen group element attached to it. So here, all the hydrogens have been replaced. So this is called fluorotrichloro. Bit tricky. Methane. And it's a refrigerant. Now here's a carbon chain, so we've got two, so it's an ethane, but we're going to number it so that the chlorine, which is the first alphabetical letter between chlorine and fluorine, has the lowest number, so it's 1 chloro, 2 fluoro, ethane. Now if you had numbered it the other way and had 2 chloro, 1 fluoro, ethane, we probably wouldn't punish you too hard. But if you went off and talked to an organic chemist, they might be upset with you. Oh, what's this? So on OneNote there'll be a little Java application, if it works, on OneNote that you can have a go and practice your naming. And in the next video we're going to look at a very important test for hydrocarbons, and that's called the bromine test. So see ya.